I want to introduce to you this framework we call QG from SymQRG, aiming to understand the AdS3 CFT2 correspondence from generalized symmetries. So the proposal is that AdS-CFT correspondence actually identifies a wave function in 3D, which is the Wheeler-DeWitt wave function, with partition functions in 2D. At a fixed point, this is the CFT partition function, and it can be written as a bra and a cat overlap. This comes from the sandwich construction in generalized symmetries. The bulk theory, which captures the symmetries of the theory, is called SymTFT. In the context of 2D CFTs, this SymTFT is coming from the Turayeviro construction or the Levy-Wien string net construction of the underlying Moore-Seiberg category of 2D CFTs. There are two boundary conditions in the SymTFT construction. There is one called physical boundary condition. They correspond to the usual Dirichlet boundary condition in AdS-CFT. And we propose that actually there's a family of such boundary conditions which has scale in them and can be interpreted as RG flows between different theories. And there's a cat state. The cat state is associated to a topological boundary condition, which captures all the OPE coefficients of the theory. Let me show you an explicit example. This is called exact and analytic 3D mirror type holographic tensor network. So recently it has been observed that we can actually get an exact tensor network representation of 2D theories from discretizing a 2D CFT path integral. Instead of the usual pair of pairs decomposition, we use open pair of pairs, which means we cut our manifolds open into triangles instead of the closed pair of pairs. And then there are boundary conditions at these red circles. We propose to sum over boundary conditions with a prescribed weight. The weight is chosen such that all the topological defect lines can move across these boundaries as if they are transparent. So topological symmetry is preserved. And the result is that then we can rewrite this partition function as an overlap between two PAPS tensor network states. One is constructed from all the BCFT OPE coefficients. These BCFT OPE coefficients have emergent meaning of the third direction attached to a boundary. This is what this picture is showing. Indeed, the third direction appears. And the omega state is constructed from the conformal blocks. So we separate out the kinematic and dynamic piece. And next, we introduce the RG procedure. Because the cat state is a topological ground state, actually it can be retriangulated. And the retriangulation is by attaching an extra layer of tetrahedron onto it, just like this diagram. When we do that, actually, instead of gluing the tetrahedron onto the cat state, now we glue it to the bra state. Then we will perform RG flow on these bra states. And when we keep doing it, we get a mirror type tensor network. So we can also introduce deformation into our theory by rescaling these bra states. When we do that, actually deform our theory away, and that actually gives the TT bar deformation. So you can see it actually manifests themselves as enlarging or shrinking the size of the holes. The deformed theories will be related by the Wheeler-DeWitt equation, which is just showing that the psi state actually is a no-flux ground state. And the above story is generic for any 2D CFTs. Now let's see where gravity comes from. Gravity comes from the fact that when we look at theories with a large number of degree of freedom, we can either look at exact series or approximately under coarse graining. Then you will see that there's a quantum group called UQSL2R appearing. And the 6J symbols attached to these quantum groups actually is just giving square of the Virasoro TQFT. So we actually see that it is this, when we preserve this amount of symmetries, we actually get the quantum gravity in the bulk.